In the previous video, we saw the proof for remainder theorem. Right. Now, today we are going to see the proof for factor theorem, another concept in polynomials. Right, factor theorem. You are familiar with the term factor. Am I right? What is the difference between the divisor and factor? These are the two terms which we frequently use in division. For example, take 8 divided by 3. I will get remainder as 2. Right. Suppose 6 divided by 3. I will get remainder as 0. In both cases I divided by 3. 8 divided by 3, 6 divided by 3. Here when 8 divided by 3 I got remainder as 2. Here 0. So here I can say 3 is a divisor of 8. Here 3 is a factor of 6. When I get remainder as 0, then the divisor becomes a factor of the dividend. When I don't get remainder 0, then divisor remains as divisor for the dividend. Right. Now, let us see what does the factor theorem say. If P of x is a polynomial, P of x is a polynomial and a, b, any real number means both rational, irrational, any real number, then, right, x minus a, linear polynomial, degree 1, x minus a is a factor of P of x if and only if. I'll tell you what do you mean by if and only if. If and only if P of a equal to 0. This is what factor theorem says. P of x a polynomial, a be any real number, then x minus a is a factor of P of x if and only if P of a equal to 0. What does it mean by if and only if? Two things are there. If and only if means x minus a is a factor of P of x if P of a equal to 0. Then reverse. P of a equal to 0 if x minus a is a factor of P of x. This is what together form if and only if. Let us see first part. Proof for the first part. Right. Given P of a equal to 0, I have to prove x minus a is a factor of P of x. Now by division algorithm, what does division algorithm says? Dividend equal to divisor into quotient plus remainder. Now here divisor is x minus a. Right, still we have not proved x minus a is a factor. So I am keeping it as a divisor, q of x. And here since divisor is of degree 1, remainder should be less, remainder degree should be less than the divisor degree. Here degree 1, so it should be a constant. Next degree is 0 only, isn't it? So when remainder degree is 0, then it's obviously a constant. See here, remainder is 2. What is its degree? X power 0. Any number raised to power of 0 is 1. So when remainder is right, when reminder's degree is 0, then that remainder is considered to be the constant. So no variable exists, so R. Alright. Now, according to remainder theorem, P of A is equal to R. by remainder theorem. So for R I am substituting P of. We saw, isn't it? We arrived at the result P of A equal to R in the remainder theorem. We are substituting that. So this is by remainder theorem. Remainder theorem. Alright. Now it is given P of A equal to 0. So for this I am substituting 0. P of A is what? Remainder. When remainder becomes 0, what happens? 3 becomes, here in this example, 3 becomes a divisor of the dividend. So in the same way here, when the remainder becomes 0, then x minus a will become a factor of P of x. Alright. So this implies, since remainder 0, I can say x minus a is a factor of P of x. Right. Now we will see one numerical example for this. Let me take P of x. For P of x, let me take, this is example, x squared minus 4. And for g of x, let me take a linear polynomial x minus 2. Given remainder 0, so I am going to substitute here, right, P of x equal to, right, x minus a, sorry, instead of x minus a, x minus 2. P of x is x squared minus 4. Q of x. Right. Plus remainder. Here remainder I am taking it as 0 because it is given remainder as 0. So once remainder is 0, what I can say here, P of x is what? X squared minus 4. Right. So once remainder is 0, then x minus 2 becomes a factor for x squared minus 4. Because once remainder is 0, the divisor becomes a factor. So thereby, since remainder is 0 given, right, automatically divisor will become a factor of the dividend. Right. Once again I repeat, here remainder 0 given. So when remainder is 0, x minus 2 is a divisor. Since remainder is 0, x minus 2 divisor becomes a factor of x squared minus 4. Right. First part we have proved. Next coming to second part. Right. Second part. What does the second part say? We have to prove. If x minus a is a factor of same division algorithm, we will take. Right. G of x, Q of x plus R of x. Right. Now, here same example we'll take later. First we'll prove it. Right. Here g of x is what? Linear polynomial. Q of x. And as I said, since divisor degree is 1, remainder degree should be 0. Thereby it becomes a constant, so no variable. Right. Now, look here. This is P of x. It is given x minus a is a factor of P of x. Right. Once this becomes a factor of P of x, there won't be any remainder. See here, once 3 becomes a factor of 6, right, remainder will be 0. Vice versa also. If remainder is 0, 3 becomes a factor. If 3 is a factor of P of x, then remainder is 0. So here it is said that x minus a is a factor of P of x. So automatically remainder should be 0. But what I need to prove, P of a is 0. So instead of x, a is here. Right. So let me substitute for x here. Right. Here e. E minus a, q of x, 0. This whole thing will become 0. Already here 0. So P of a is 0. Thus prove. Second part also we prove. So if x minus a is a factor of q of x, then p of a will become 0. Fine. Now, like in the first part, no need to substitute for our p of a here, because here p of a equal to 0 given. So for r you substituted p of a by remainder theorem. But here p of a equal to 0 we have to prove. That's why for r just I have substituted 0, because it is given x minus a is a factor of p of x. Once factor, very obvious that remainder should be 0. Since p of a equal to 0 we have to prove. Wherever x I substituted a, thereby I got p of a equal to 0. Like part 1, let me give example for this. Second part. Same example I take. P of x, x squared minus 4, g of x, x minus 2 linear polynomial. Right. Now here, second part, it's a factor it is given. X minus 2 is a factor of. So let me substitute here. Right. If it is a factor, p of a is 0. Right. Here, let me write this. Right. X minus, I am going to substitute my example here. Right. I am taking this. Right. Here in the place of a, what is there? 2. X minus a. So in the place of a, 2 is there. Right. Now, here it is given x minus a is a factor. X minus a, x minus 2 is a factor of what? X squared minus 4. Right. So here q of x, and it's, we have to prove p of a is 0. Once x minus 2 is a factor of p of x. P of x is here what? X squared minus 4. Once it is given x minus a is a factor of p of x, the remainder should be what? 0. But what I need to prove? P of a equal to 0. Here a is what? Here a is 2. Here p of a equal to 0 I have to prove in the place of a 2. So p of 2 equal to, right, p of 2 equal to, wherever x I am substituting 2. See here, wherever x I am substituting 2. So 2 minus 2. That's what I did here, isn't it? Q of x plus, since the whole thing becomes 0. So p of 2 equal to 0. See, through example also I showed that if x minus 2 is a factor of p of x, that is x squared minus 4, then p of a equal to 0. In the place of a, what is there? 2 is there. In the place of a, 2 is there. So I substituted for x 2. P of a, p of x, same form, isn't it? So for x I have substituted a value. A value is 2 here. So p of 2 is, wherever x I have to substitute that a value. I got p of 2 equal to 0, like I got p of a equal to 0. Right. This is what the proof of the remainder theorem with example. Right. Once again, can I recap? Factor theorem says if p of x is a polynomial and a be any real number, then x minus a is a factor of p of x if and only if p of a equal to 0. If and only if means x minus a is a factor of p of x if p of a equal to 0. P of a equal to 0 if x minus a is a factor of p of x. So I took the division algorithm first. Then since the degree 1, remainder degree should be 0. So thereby r becomes constant. By remainder theorem, p of a equal to r, we already proved it. Right. So here given p of a is 0. Once remainder p of a is what? Remainder. Once remainder becomes 0, divisor will become a factor. Thereby x minus a becomes a factor of p of x. Example I gave. P of x I took x squared minus 4. G of x, x minus 2. Since it is given remainder 0, x minus 2 will become a factor of p of x. Correctly, this will divide this. You can see correctly it divides this. See here, you want to see x minus x, can I do it here? See, x minus 2, here x squared minus 4, x squared, no x term, so put 0 minus 4. So what I will get, right here, x into x, so I will get x squared minus 2x, right. Now subtract root, I will get minus minus plus, subtract root, isn't it? So plus 2x minus 4, right. Now minus plus 2x I want, so plus 2, right. So 2 into x, 2x minus 4. Now subtract, I subtracted, right, minus minus plus 4, so whole thing will become 0. So I checked, when remainder is given 0, x minus 2 becomes a factor of x squared minus 4. So I checked it, no? X minus 2 is a factor of x squared minus 4. Correctly it is dividing and we are getting 0. So here 0 given, remainder 0 given, then automatically the divisor should become a factor of its dividend. Right. This is what the example, through example I showed. Then coming to the second part. Second part is given x minus a is a factor. We have to prove p of a equal to 0. I taken the division algorithm. Since degree 1, remainder degree is 0. So thereby remainder is constant. And it is here, once it says x minus a is a factor, remainder should automatically become 0. Right. So but we want to prove p of a equal to 0. For x I substituted a wherever x. So I got p of a equal to 0. In example, instead of p of x, x squared minus 4, and instead of x minus a, x minus 2. So in the place of a, 2 is there, q of x. Right. Since it is given x minus a is a factor, x minus 2 is a factor, remainder is 0. Right. But we want to prove p of a equal to 0. What is a value? 2. So wherever x I am substituting 2. Right, because for x I have to because p of a equal to 0 I have to prove. In the place of x, a is what? In the place of x, a, p of a. So in the place of a, what is there? Number 2, x minus a. So p of 2, wherever x I substituted 2, so I got p of 2 equal to 0, which is same as p of a equal to 0. So through numerical example also I proved the factor theorem. I hope you would have understood. Right, though it has taken some time, just you should not mug up the statement of factor theorem and remainder theorem. You should know how we have to prove it. Right, how it came. Right, so we need to understand the proof of the factor theorem and remainder theorem. That's why I took some effort to make you understand with numerical example too. Thank you. In the next video we will see some more concepts based on the polynomial chapter 2 class 9. Right. Thank you children. Thank you so much.